That car was a unique one too from that perspective because we never put it on a dyno. That's another one that
Really?
Yeah, never touched a dyno before it went to the mountain. So there was no testing whatsoever. It drove through tech and then they went from tech to a local track. And the guy would make a lap and I would log in remotely because I couldn't go there that year.
On this episode of Tuned In, we've got Sander Marques joining us from Obsidian Motorsport Group in the US. And we've known Sander for a fair while, and he's probably one of the smartest people that I've met in the motorsport industry. He's got a fairly wide-ranging skill set, and he's been instrumental in some pretty cool projects. In particular, today we talk about his calibration and configuration work on the Motec suite of electronics on the BBI Autosport Porsche GT3 twin turbo, bit of a mouthful there, that competed at Pikes Peak originally in 2019 and won the class as well as setting a new record, and also competed again just recently in 2021, again winning its class and coming fifth outright. An interesting aspect of that build is that the whole thing was done in only a month, and Sander actually completely tuned that car, which at the time was making around 850 horsepower once they actually got it on a dyno. He completed the full calibration of that car remotely, and it never went on a dyno. So we quite often get asked about the process of road tuning, whether that is viable, whether we can actually get good results. And a class win and a lap record, a record up Pikes Peak, it goes to show that yes, absolutely 100% it can be done. There's a little bit that goes into that though, of course, so we'll get into that as we go through the interview. Before we get into that, and just touching on that aspect of road tuning as well, if you are interested in learning how to road tune, there are some limitations of course around that, but if you are interested in learning, we do include segments on road tuning in both of our practical tuning courses. That includes our practical standalone tuning course, which is perfect for anyone who wants to learn how to tune an aftermarket standalone ECU, irrespective of what brand of ECU that is or what engine you want to tune. And we also cover road tuning as well in our practical reflash tuning course, which is perfect for those of you, of course, who want to learn how to reflash a factory fitted ECU. It's a process that's becoming much more commonplace, particularly with late model cars as they get more complex. So we'll go through the process in that course of the tuning on a dyno. Of course, we have our own dyno, and that's how a lot of people will be doing their tuning. But we do have customers that come from cities and even sometimes countries around the world where there are simply no local dynos, and in that situation, you've got no choice. As I mentioned, yes, there are some limitations, specifically around really optimizing and fine-tuning the ignition timing. It's, of course, impossible to know exactly where MBT is for our ignition timing if we don't have the benefit of feedback on engine torque, or maybe if the budget allows, in cylinder pressure monitoring. But we can still do a really good job of getting the tune dialed in, and a lot of our customers will use the road tuning additions to our courses in order to get their tune dialed in close, where their only cost is maybe a tank of fuel and some time after hours after their job or in the weekend. And then once they've got that tune dialed in and everything's really close, they can then finish it off and optimize everything with just maybe 1 or 2 hours of dyno time. So it's a very viable option for your tuning. As a listener to this podcast as well, you can use the coupon code podcast75, and that's going to give you $75 off the purchase of your first HPA course. We'll put a link into the description for both of those practical tuning courses if you are interested in learning about tuning as well as the road tuning aspect of it. Okay, with our introduction out of the way, let's jump into our interview with Sander now. Welcome along to the podcast there, Sander. Thanks for joining us today. And I think, without trying to make your head expand here, over the years I've been involved with HPA, I've had the pleasure of meeting and interviewing some really smart people, and I think you're right up near the top of that list. Some of the stuff we've talked about over PRI and SEMA adventures has been pretty mind-blowing, and I'm really looking forward to diving in a bit deeper on some of this stuff as we go through about the next hour. I think for those who maybe haven't heard your name before, though, could you just start by maybe giving us a quick rundown on your background, how you got into tuning and electronics?
Yeah, sure. Thanks for having me here. So my name is Sander. I've been doing things in the automotive world for quite a number of years. Right now, I'm doing mostly things based around Motec M1, Motec M1 build specifically, and inertial sensing. Maybe we'll talk about that later, I'm sure. My background is I started as a 15-year-old working as basically a shop bitch, doing chores and work around an automotive shop, and I couldn't have been happier. I thought it was like the greatest job ever. And I learned tons of lessons about life, among many things, but also about how to diagnose problems and just general problem-solving mentality. So I worked there till I was for a number of years, and then I started working in the performance tuning world right around 2006, 2005 maybe. And I was tuning Hondata back when it was a staged system. So you would have a Hondata Stage 4, just long before S100, 200, or 300. And I didn't really know what I was doing. I had a car at myself, my own personal car, and I was messing with it, and friends needed help with it, and that sort of progressed on from there.
So how did you make that transition from shop bitch to learning how to tune this Hondata platform? Did you already have a background in sort of EFI, or was it sort of straight in the deep end?
No, the thing that I was so fortunate about with this working at this shop was that the two guys that owned it were just delightful humans, and they really took a lot of time with me to sort of teach me the basics. So if I had a problem with a car, they would say, like, hey, go diagnose this, whatever, AC doesn't work. And I would come back and say, well, I think it's this relay that's bad. Let me just replace the relay. And then they would be like, okay, that's fine. Well, you need to show me why the relay is bad. And this sort of thinking progressed along, and that eventually I just was just totally obsessed with powertrain, engine controls, and engines in general. And then those guys helped me with the basics there. So by the time I got into messing with Hondata, like I had mentioned, I felt like I had a pretty good foundation of like how to diagnose problems. To do that, you need to know the fundamentals, and they certainly helped me with that.
I think that's a really important aspect that is so easy to overlook for those who are wanting to get into the performance automotive industry, particularly as tuners. And we see a lot of people who come into this who've got no formal background in automotive mechanics. And you definitely don't need to be a mechanic to tune an engine. But what I still remember vividly, the shop I used to run, probably 4 in every 5 cars that we put on the dyno would not just go on the dyno, get tuned, and then roll out the door. There would inevitably be some level of problem, and at some point it can be really, if you don't have that mechanical experience, it can be really tempting to just sit there in the comfort of the driver's seat, punching buttons on a laptop keyboard and going nowhere. But at some point you've got to actually diagnose the root cause. So that background understanding of the mechanical system, how the engine works, how the fuel system works, that's so key to being able to kind of go down a sensible path and a sensible approach to actually efficiently fault finding and fixing those issues. And that skill, I do sadly believe, is being lost a bit these days.
Yeah, and it's just the sort of current state of all the things you need to know to be a mechanic today. It's orders of magnitude more than it would have been even 20 years ago, 10 years ago, just with this sort of complexity. So I think the basics get lost in the sort of training of that, and that's sad in my mind. But
agreed.
Anyway, yeah. So I started with that. I always liked computers. I was like a big nerd through most of well, I guess I'm still a big nerd, but I was definitely a big nerd in high school and middle school and high school. And I just like computers, and I like cars, and these things merged together when I started messing with Hondata.
Sure.
And it continued on from there. And I just sort of, whatever it would be, almost 20 years later now, I'm here surrounded by robots and computers and cars. So it's a good place to be.
So what was the jump from Hondata to your own business and also the move towards Motec? I mean, those are poles apart. So can you sort of fill in the blanks there for us quickly?
Yeah, so quickly is hard, but I'll do my best. So going from when I started messing with my own car, I had mentioned that I had lots of friends that had Honda stuff. This was like street racing was really big, especially near where I am in Baltimore, and it was just, you were the guy to know if you knew like how EFI worked and you knew how Honda worked. And I had tuned lots of cars, and I realized I could charge money for it and still keep a normal job because I was doing this at night. Yeah, so then I started, the frequency of tunes that I was doing was going up, but the quality was, I wouldn't say going down, but it was just stagnating. Like it was just so much. And I wanted to differentiate and get out of that. So in 2008, I took a class. Oh, this may be bad. This is from one of your competitors.
Go ahead.
There was an in-person class by another school that was doing tuning at the time. And the class was actually, it was a Motec V3 class that was designed by Shane and Paul Yaw, I think, actually. Maybe Shane did most of it, I don't know. But the thing that just really, it lit this like insatiable sort of desire within me to learn everything about Motec was the M800, because the axis on axis, the sort of the possibilities of this like are exponential, right?
When they made that change to their version 3 firmware, it was really a game changer. And I mean, even to this day, I know a lot of people who are still using the M800 over the M1 because arguably, or even not arguably, outside of build, the flexibility to you could do almost anything you could come up with a bit of thought and how you're going to manipulate the different axes for these tables, which unfortunately, at least in the production firmware for M1, a little bit of that I think has been lost.
I would say more than a little bit. I mean, you're very with GP packages. They're great. Motec's done a phenomenal job of like getting it roughly there, but the creativity spark is certainly gone in a production package. They want you to do that in build, which we can talk about later. But so anyway, I had taken that class, and I think it was 2 days, and I was in California. I don't remember, Southern California. And I remember leaving there and just being like, I want nothing more in my life than to be able to sell and represent Motec products. So I was just so drinking the Kool-Aid at that point. And, I couldn't, at the time, like I didn't have the clientele that could kind of fork the money over for, an unlocked M800 with all options and stuff. And so it was a hard sell.
Come at a price point.
Yeah, for sure. I sort of didn't let that deter me. I was like trying to save up money to buy an M800 so I could just have one on my desk and poke at it, because I just thought that was super cool to do that. And eventually I found one local Porsche guy that was willing to, well, sorry, let me back up. I attended a number of dealer training seminars which was a requirement, maybe still is, at Motec USA, to be able to become a dealer. You need to go through this whole week of training, which is ECU-PDM, I2, maybe even, I think build was a requirement at the time. And the last thing you needed was to be able to sell one unit before you could be a dealer at retail. And I found a friend that was willing to buy an M84 for his Porsche, because it was the cheapest one that I could sell and become a dealer. So I was like very thankful for him to be able to write the check to like basically allow me to become a dealer. And the guys at Motec USA, specifically Dave Gibson, were just awesome to deal with.
I think that training, I just want to talk to that for a moment there, because I think that is really important. And I mean, obviously the Motec product is at a higher price point, so there's some abilities around there that probably don't come at the more sort of entry level ECU range. But a problem I constantly see, because I used to end up retuning a lot of cars that had been set up poorly, is the ECU manufacturers often look at the bottom line first and think, well, the more dealers we've got out there, the more units we're going to sell, so happy days. And of course, the problem is that we get a lot of tuners out there who unfortunately don't really understand the basics of tuning, do a horrible job, don't understand the product, don't set it up properly. At the end of the day, it's the customer that's going to have to live with that. And particularly to the customer, if the car starts horribly when it's cold, doesn't idle properly, has poor drivability, quite often the end result of that is they end up blaming the ECU, and the ECU manufacturer gets a bad rap. So I think it's good that Motec actually go above and beyond with that training strategy. So I mean, I'm sure there's still Motec dealers out there who maybe aren't working at the highest level, but it kind of at least brings in this sort of minimum viable level that they need to be at to do a good job with the product.
Yeah, I totally 100% agree. And I really can't speak enough to the time that I had gotten involved with Motec as a dealer. I think was early 2010, maybe 2011. Maybe 2012. I can't remember. It's all kind of blurring together. But anyway, the week of training, it was expensive, and becoming a dealer cost a lot of time and money. But I repeated the same week the following year because I continued to get more out of it. Even hearing the same material, like if you think of a question during the first year, you take it and you're like, oh, I wonder why that is that way. And then you go back again. Like I just can't speak enough to the importance of understanding the low level sort of functionality and how things are working and why things are doing what they're doing. It's just
absolutely
incomprehensibly important. And that kind of, at that point when I had become a dealer, I used these, my first sort of electronic product that I ever made and wanted to sell was using GymStim Megasport simulators, and I had built wiring harnesses to adapt them to different popular ECUs. So and my only goal with those was to save enough money, like to make enough money to buy a Sim 3. So it was sort of a Motec simulator, I should say, specifically for Sim 3.
So it was a means to an end.
It was and it never worked out. Like I just was so in the red on that whole project, but it just took so much time. And I think it was like my first lesson in sort of trying to do market research through social media, because I didn't have a following, and I certainly don't really at this point even, but I had asked people like, hey, would you buy a simulator if it was $500? So you could run its ECU on the desk and check CAN stuff, or just make sure stage injection's working like you think it does, or flex fuel or whatever. And everybody was like, yeah, I'll totally buy that. That's a really great idea. And then as soon as I made like a bunch of them, and I had to hand assemble these, like I'd buy these GymStim kits from Megasport, and I would set them up such that they would work with normal type ignition drivers, not like a dumb coil, as it were.
Yep.
And made it so you could plug it into the thing and like flip a switch on, and you could get a crank signal, and it was really easy. And I was like kind of proud of it. And it just, man, I still have them sitting back there, and I'll get a note every once in a while from somebody that's like, yeah, are you still selling these? And I'm like, no, go away. Don't
go away.
I don't ever want to sell these again.
Sometimes you've got to go through a failed project and realize maybe what the market wants. Maybe those people are sort of said initially $500. Yep, I'll take one. And then, when you actually put it in front of them, oh no, not now. No, I don't have $500. Sorry,
I'll let you know.
Yeah. I'll be back to you next year. So let's talk about the transition from the 100 series ECUs from Motec to M1, which is definitely not a new platform now. It's pretty grown up and established. What's your sort of take on that? What did that offer over the M800 for you? And do you see that was a step up? We'll get into M1 build in a moment.
Yeah. I mean, for sure, even just stepping aside from build or all the flexibility that provides you, it's for sure a step up just from the simple fact that, like, if you enter all the base parameters right on a car with M1 that's wired properly, like in a perfect world, you can put one number in the VE table and it'll pretty much run okay. Like if you put 80, 85, or 100 in the VE table, it should start up and run and idle. May not be perfect, but it'll get you close. Doing that in M800 is not. It takes more Motec specific knowledge with crips and sort of setting up the trigger patterns correctly. Whereas M1, you have the sort of endless number of drop-down menus for pre-configured stuff to make that more easy.
So you're basically choosing a trigger pattern specific to the engine you're working on, and kind of the hard work of it. At least you've mentioned crip, which for non-Motec users probably they won't understand, but basically that's in the older Motec ECUs, how we align the timing or set the base timing so that the trigger event, the spark event I should say, was actually occurring at the right point. What the laptop said is what you'd see on the timing light, whereas at least with a lot of the fixed trigger patterns on these engines now, as you say, that's just done from a drop-down menu, and we're basically good to go.
Yeah, more or less. I mean, there's still a timing offset number that's sort of similar to crip in M1, as you know, but they'll usually give you like a guideline, like, it should be 40 degrees or whatever. But the point being less about ignition timing settings or offset settings. Is just that M1 is much easier than M800, and using a VE model as opposed to a pulse width model, like, you sort of get a lot of free stuff with that. Let's
actually talk about that, because we do quite often get asked, VE models now are pretty common on most mainstream aftermarket ECUs. Everyone's sort of switched to that. I don't know. I think a lot of people at the time that was starting to come around thought that was just sort of a marketing ploy or a new buzzword. But it's not. So give us your take on injection pulse width or injection time-based fuel models versus volumetric efficiency fuel models. Where are the advantages? And maybe even at a higher level, could you sort of break down what a VE model actually is?
Yeah, sure. So, I mean, to start, a volumetric efficiency model is trying to model air passing through a motor, where pulse width is just a number that you apply to an injector. So it's like a lookup table only. There are still examples of ECUs that are current today that use pulse width lookup tables. Yep. Life and Cyvex specifically are ones that still do.
Yep, absolutely.
But the volumetric efficiency type ECUs, what falls out of that is this stuff that's relevant for modern sort of highly electronic sports cars, which is torque. So it's, sort of trying to estimate engine parameters is a much simpler thing than trying to do all the math from injector pulse width. There's certainly, you could obviously do all the same stuff that a VE ECU does with a pulse width ECU. It's just the VE ECU is doing more work for you. It's doing more of the math for you. I go a lot of back and forth on this. From a high level, I think VE ECUs are nice because it makes roughing a map in to get a car running in the ballpark much easier, in my mind, if you have correct injector data.
Like you said, if you've got the correct injector data, you could literally put a number of 60 or 80% across the whole VE table. It won't be right, but it's going to let the engine get up and running. Whereas if you're looking at an injection time-based ECU, well, 2 milliseconds on a 500cc injector versus 2 millisecond pulse width on a 1000cc injector. Obviously, we're completely, quantum leaps different in the amount of fuel being delivered. So understanding the injector size versus the injector pulse width that's being delivered, or in some SUs, they go a step further. It's not directly a millisecond number in the fuel table. We're actually looking at a percentage of a master injector pulse width, which adds another layer of complexity. And understanding that, and then also comes down to the relationship between your master injector pulse width that's going to affect the resolution you end up with in the table as well, which I see a lot of tuners get wrong. So, they might end up with a fuel table that the maximum value is sitting at 40%, which doesn't give us a lot of resolution. Each change we make in that table has a coarser effect on the air fuel ratio.
Yeah, totally agree in all aspects there. Another easy advantage is that you can look at a dyno chart and then assume where peak torque is and sort of call that 120, and just that'll probably be fine to taper off from there if that's what the torque curve does. The one thing that I find sad and a little disheartening about VE stuff is that it gets back to the sort of original topic that we had, was just the basics. You don't have to have a grasp for that. Like if you choose the correct injector data and you choose the right displacement of the motor and you've got cylinder count right and all the fuel properties and stuff done correctly, you don't really need to know why. With an injector pulse width ECU, you also don't need to know why, but it sort of exposes, I don't know. Maybe it's because I have old Excel spreadsheets that I could create, like VE models from like a big injector pulse width chart. Yeah. But I don't know. I'm sort of fall under that like old curmudgeon tuner guy when it comes to that. Like I think it's important to know how and why it's working. So that's hard. I've got lots of feelings about that. Yeah.
All right, so let's just go back to another aspect you mentioned there. There's two parts here. You said if you've got a torque curve up on a dyno screen, you can sort of look at peak torque and where that's occurring and call that 120% VE and then taper off. And I mean, again, not going to be perfect, but probably there or thereabouts at least. And I think the thing that a lot of people maybe miss is when we're looking at a torque curve, really, that on the dyno, that's representing the airflow through the engine. So essentially that torque curve is going to have a very similar shape to our VE curve in our table, correct? Yeah.
And then the what's also true is injector duty cycles should represent horsepower, right?
Yes.
Yeah. So like these are good rational checks to see if you're some idiot that doesn't have a fuel pressure sensor and your VE table is just like going to the moon, you can probably logically deduce that you have a fuel problem. You have a supply problem.
I'm pleased you brought that up. We actually discuss that exact aspect in our FI Tuning Fundamentals course, because this is probably one of the more common issues I would see when tuning on maybe an older car where there was some fuel system problem and maybe you didn't have full monitoring of things like fuel pressure. And you do a dyno run and maybe towards 7,500 RPM, maybe we're starting to run a little bit lean. Well, okay, obviously we'll just go and add a little bit more to the fuel table there, and you do another run and lo and behold, it's no different. And 3-4 runs later and you've got this exponential shape to your fuel curve and yet you're still lean. And that should straight away be a sign, once you're starting to deviate away from the shape of the torque curve, you got it ramping up at higher RPM. Well, that's not normal. So this is a red flag, alarm bell. Something else is wrong. Figure out what that issue is.
Yeah, a sign that it's good to go and you've done your job. Sorry, that's sarcasm.
I get it.
Yeah.
So you mentioned that one of the advantages with the VE fuel model is that jump from volumetric efficiency to engine torque, which is so important for some of these late model engine management systems, becomes simpler. There's less of a jump. How do we get from VE to torque?
Yeah, so it's what falls out of airflow. Knowing airflow is really the big sort of result of a volumetric efficiency based ECU. There are a lot of things that factor into estimating torque correctly, and that has to do with frictional losses and sort of accurate data going into this input. But you can basically, it's an equation away from airflow passing through the motor, so mass flow through the motor, I should say.
And once you've got that torque, then that allows a lot of other things to be done around torque requests, particularly when we're dealing with maybe some of the dual clutch transmissions, or where there's that interaction between the transmission control and the ECU.
Yeah, the GTR is a good example. The Motec plug and play for the GTR is quite good. I don't do really any of those cars, the Huracan or the GTR specifically, but the package that they've written for that, I know that they've gone through extensive lengths to try to make sure that the torque request value being sent to the TCM is accurate, so that the car doesn't drive like shit, or shift badly or whatever. Yeah.
All right. So just coming back to M1 build, and that's sort of one of the key advantages for those who are a little bit more sophisticated, let's call it nerdy. But could you, again, for those who maybe have never heard M1 build, never heard that term, can you give us a sort of 30,000 foot overview of what M1 build is, what that sort of ecosphere actually involves?
Sure. Yeah, for me, it's the same. It sparked the same sort of love and passion for Motec products that the original V3 M800 did, in that it allows you to not complain to Motec about features that they don't have. It allows you
with, yourself.
Yeah, exactly. So it allows you to take something like, if I'll make an example here. If the lambda control for M1, it's not my favorite of the features in that ECU, and instead of like writing up some long-winded, pointless post on social media about how Motec sucks and the M1 lambda control is terrible, I can go fix it. And if I wanted to have a traditional PID loop, I can do that. And that's the power of that is just so immense. And it's that type of, they've done this magical thing with M1 build that allows relatively novice programmers and engine tuners, or the special combination of both, which I think I sort of fall into a little bit, to make the changes to the ECU that they want to make. And this is done in NASCAR. This is done in much higher levels of motorsport, where you can basically, in the case of NASCAR, McLaren or TAG will give you this box that's an ECU, and you can use their system monitor software, which is their like tuning interface, and you can make the engine run fine. But a lot of the top teams have their own, we'll call it firmware in this case, to run the motor as they would like.
Sure.
And so it gives them the sort of ability to do what they want with it. Yeah, exactly. And to circle back to your question, what is build? Build for me and build for everyone is really the ability to go add sensors, add functions, add very powerful CAN, receive, and transmit stuff to an ECU. But it doesn't have anything that'll get you into really deep shit. So you can't do for loops or while loops. So for people that are programming, these are sort of logic loops that you can get stuck in and crash the computer. So they've done it such that it's more like a ladder, what's referred to as a ladder logic controller. So it's really just a bunch of if-else statements and an automatic scheduler, so that you can't, it's really hard. It's possible, but it's really hard to program yourself into a really bad situation with build. It does that stuff very well.
So in a nutshell, what we're doing with build is essentially treating the ECU as just an electronic black box, and that little black box will then do whatever we tell it to via the firmware that we generate and build. And we are seeing those ECUs used in completely non-automotive applications as well for industrial control, etc., because, again, it's just going to do whatever it's told to via its programming.
That's exactly right. And one of the things I don't think the Motec engineers that have willed this product into existence get enough credit for is the simplicity and the flexibility, but not over complexity.
They're basically walking a bit of a tightrope there, giving enough control without making it so complex that you need a PhD to be able to actually use the software.
For sure. It's not bare metal programming. This is what the sort of industry term would be called. So you're not having to deal with sort of library linking or any of this memory management or scheduling or interrupts. That removes some power to M1 build. For instance, there's a particular function that I would like that to be in there that will never be in there because they sort of, it occupies this sort of middle level between M1 Tune. The user interface would be this high level where you're changing numbers and making things sort of affecting the inputs into the computer. Build is this middle level where you can change the functions between the high level and the actual chips on the ECU. And then the low level is this stuff that only Motec has access to, which is the sort of base programming that gives you all this flexibility, but it comes with great risk to crash your computer or get into a bad scenario. So it's really a wonderful middle ground there.
It sounds like they've probably got the right balance there, not that I come at this from a programmer's perspective, but I've played around with build and I've managed to make my own functions, which for all intents and purposes, and if a programmer, maybe someone like yourself, looked at it, you'd probably laugh at my code, but at the end of the day, I kind of got the job done. So, which actually sort of segues nicely into the next question, which, as I mentioned, I've had a little bit of experience with. But when we're talking about programming and writing code, like, this is a very different skill set from the mainstream engine tuner. Can a mainstream tuner who hasn't got that sort of college education in coding adapt and work in the build environment?
Yeah. There's you don't need any kind of, and to be clear, I mean, just as a total side note, there's nothing that says that anybody needs any type of advanced degree to do anything. I think to do specific, and especially not in build. The language of build is like C, but C code, if you're writing it at a microcontroller level, is much more complex, even in a environment like an Arduino, like a small little microcontroller that you make LEDs turn on and off. Build is much simpler than that. The syntax takes a little bit of time to get used to, but you can do, like, I listened to your podcast, your talk with Shane, and what Shane had said is totally correct. If you want to copy and paste, if you want to add a third wastegate or something silly like that, you can copy the wastegate position bank 2 and make it bank 3, or just something like that. Literally copy and paste it.
I think it's probably important, again, for those who are maybe listening to this and have no understanding of that Motec environment at all as well. Like, while yes, you can literally treat it like a clean sheet of paper, almost no one is doing that, and you're starting from
almost
an existing project most of the time. So all of the stuff's in there to actually run the engine, control the injectors, the ignition, etc. And then it's a case of you could do something as simple as changing what the axis is for your main efficiency table, or you could then add your own functionality. So it can be as simple or as complex as you want it to be. And again, just to kind of give a little bit from my own sort of experience with this system, and coming from a non-coder's, non-programmer's perspective, it's not rocket science, because what you get the ability to do is have a look through the existing code and see, I can see how they've laid this out and how this function works. And a bit of sort of research into that and understanding how Motec are doing it, then you can apply that same sort of logic to your own functions. And I mean, I just started with something simple and tested until it worked. And it's a bit of trial and error. So I think it is achievable. Probably also worth mentioning for those who maybe want some functions written and don't want to go down that rabbit hole of learning. There are specialist companies out there, Motec dealers, who do write code for third parties as well, correct?
Yep. I'm one of those companies. Most of my business now is basically just doing private label build development for most of Obsidian's business is doing private label M1 build development for other dealers, not even just end users. And that's been fun because a lot of people have really great ideas that are really interesting and compelling and just don't either have the time or the want to write it and build themselves. And it's been fun to be a part of some of those interesting projects.
Sure. All right, I think we've probably done that to death. And before everyone falls asleep thinking about writing code, I wanted to jump into a slightly different topic, which is being prominent for your company over the last few years, back to 2019, which is the BBI Autosport Porsche GT3. Twin turbo GT3 that you competed with at Pikes Peak. Well, you're in charge of the calibration configuration. And I remember watching the YouTube build of that. It was built in some insanely short time frame, like a month before Pikes Peak 2019, which usually doesn't go too well. But in this case, it worked out perfectly. Can you tell us how you came to be involved with that project?
Yeah, for sure. That was sort of a confluence of events that led me into that project. So BBI Autosport, for those who don't know, is in Huntington Beach, California, so Southern California. I was living in San Francisco at the time, so that's a couple hours north of there. And I had a very good friend of mine who was doing a lot of the engineering work on that car, had asked for just basically about a little more than a month before, had just like frantically pleaded for me to join their project to help them sort of get that car to the mountain. And honestly, we weren't even thinking about a record at the time. We just wanted to make it and make a clean run up the hill. So it was a lot of work in a short period of time, and it certainly wasn't just me, but it was a lot of people coming together to make that project happen. So that was It's a 991 GT3 Cup America that BBI had built a motor for and a twin turbo kit, and then there was a suite of Motec electronics, PDM30, C127, and M150.
So you came into this project, from what I understand, the electronics package was already basically installed in the car, and you had a wiring harness in there. So your job was sort of come in and configure everything and get it up and running and calibrate it?
Yeah, that's exactly right. So everything was blank. The ECU didn't have firmware on it. It was PDM had nothing on it. Dash had nothing on it. So it was just sort of to set it up such that they wanted to reach their goals and make the car run reliably. And it has every sensor you could ever want on it, except for individual cylinder lambda. But pretty much everything else you can imagine was on there.
Okay. Are you running custom firmware on that particular car?
Yeah, so that has a development license on the car. So yes, as a result, it's custom firmware that I had written. And I had worked with BBI and also Mitch and John from M Engineering to sort of make a good plan to what's needed to make that car reliable. And I had basically just sat there and worked away at it to make sure that we would have no issues with turbo speed at altitude, and make sure the car ran well from the base to the mountain, or the base to the summit, which is quite an altitude split.
Sure.
And yeah, that car was a unique one too from that perspective, because we never put it on a dyno. That's another one that, never touched a dyno before it went to the mountain. So there was no testing whatsoever. It drove through tech, and then they went from tech in 2019 to a local track, and the guy would make a lap and I would log in remotely because I couldn't go there that year. and we were just basically touching the map up one lap at a time, and it sort of all eventually came together.
Is this where it comes back to, because it's VE based, you had that sort of
Exactly.
leg up and could get to the track? But what are you then basing? Obviously, you've got feedback on lambda, so you know where your air fuel ratio is and where it's rich or lean. I'm assuming you're probably also relying with a pretty untuned map like that on closed loop lambda to correct any errors that are there. That part's easy, but when you've got a complex engine with variable cam control, I assume it's still got variable cam control, and you've also got ignition timing to deal with. So, how are you optimizing those aspects? I don't know if I'm speaking out of turn on the cam control aspect.
Oh no, you're quite right. So that engine is more closely based to I think it's a 997 turbo engine. So the chassis is a 991 Cup, but the engine is a 997 turbo. So it only has single intake cam, so it's not intake and exhaust. And the intake cam profiles, again, because of the time frame, we if you've tuned enough cars with a variable inlet cam, you can sort of assume what the cam advance profile is going to need to look like, where you advance the intake cam near peak torque and then taper it off as engine speed increases.
Yep.
So that's not terribly difficult. The closed loop stuff needed a little touching. So like the low level closed loop control of the cam was close with some sort of settings I had from another turbo car I had done in years past. And with respect to the ignition timing map, also a valid question. There's no sensible way to validate that remotely. We don't have torque sensors. We don't have any of these good ways to do that. So this is where a lot of the sort of input and experience with water-cooled turbo cars that Mitch and John from M Engineering were able to sort of help point me in the right direction in terms of like, what's a safe number for this boost level, and then we can bring it down from there and watch knock sensors and so much. But the objective there again was to be very safe. We were not that car was not on the edge whatsoever. We were just happy to make it up.
In terms of power levels, I think it's quoted at the moment this year. I saw some numbers bandied around the 1100 horsepower mark, which is obviously not messing around there. And in terms of Pikes Peak as well, you've already mentioned turbo speed. So the boost control, particularly at Pikes Peak, is quite critical. I want to sort of get a sense of like, what are you doing there? You talked about some custom firmware for safety strategies. What were you running on this, and sort of give us a bit of an overview of the custom stuff that you're doing in there to get these results?
Yeah, so there's a number of little custom things that aren't particularly interesting. One of which is CAN integration for the Megaline stuff that's stock in that car. So Megaline is a company that makes pneumatic gear shift electronics, and it's nice to use their products because their valve bodies CAN outputs, the compressor has CAN outputs, so we can log all of that data to make sure the compressor is not overrunning. So there were safeties in there for that. You'd spot if there's a leak, basically because there's a percentage ratio of how often the compressor runs versus not running. And if the run time is higher than the not run time, you'll get this sort of creep scenario where the pump can overheat and then it would shut off. So it's an easy way to detect leaks. So that's one thing. With respect to turbo speed, I implemented a turbo speed control, boost control. So it's basically targeting turbo speed, not manifold pressure. Because the turbos we were using were G30 900 Garrett's. And we basically just wanted to set it up such that at the base of the mountain around 9,000 feet, we would be able to target maximum. I mean, just basically at the end, if you know what a compressor map, the top the top right of the compressor map, we were basically just trying to keep it there from the base to the top. And as a result, that winds up you're pulling boost out of it, as a result as it goes up, so that they don't overspeed. And we were able to keep the turbo speed the same at the bottom as it was at the top. And that was really the main objective, so we don't shit parts out of the side of it or anything.
Yeah, I think that's easy to overlook. Is when you've got massive changes in barometric air pressure at the likes of Pikes Peak, people look at a turbocharger and it's obviously the boost pressure is the important part, but it's really, as far as the compressor is concerned, it's the pressure ratio, which is the ratio between the inlet pressure, typically somewhere pretty close to barometric, and the compressor outlet. And of course, as the inlet pressure drops, the barometric air pressure drops as we go up the mountain. If we're maintaining the same manifold pressure, that pressure ratio is constantly climbing. And in order to achieve that, if we're looking at the turbo speed, that is also constantly climbing. And then we get to a point where we overspeed the turbo and often they fall apart. So obviously not the way to get a result.
So again, we were, if you want to think of it, we were losing power as we were going up. So we're not targeting constant power. We're targeting constant speed, turbo speed at that.
Yeah.
It's a funny balance at Pikes Peak specifically, because there are such low speed turns that you can't. I wanted to put much larger turbos on it because it's less fun to pull power out of it as it goes up, and more fun to keep it the same. But that was not in the cards for this. And even with anti-lag at that, and those turbos, which are not particularly large for the displacement of the engine, it was still a little laggy, as it at really low RPM. So we didn't have bypass valves in the exhaust. So yeah.
I noticed that with the car that I tuned, that we took to Pikes Peak, and here in Queenstown, essentially a bit over sea level. The thing was super responsive. We're all in by 3,500 RPM, and we get to Pikes Peak on the first day of testing, and we've got 1,000 RPM more lag before the things are at full boost. And it really sort of opens your eyes to the effects of altitude that. We just don't see those sort of altitude changes here in New Zealand, so I didn't have an understanding of what I was actually going to be facing. So choosing the turbo size so that you're not going to be overspeeding the turbo at 14,000 feet, but still getting response, particularly through that middle section, the switchbacks is pretty tricky.
Yeah.
You just mentioned anti-lag as well, so you were relying on an anti-lag strategy.
Mm-hmm. So we used anti-lag also, but we didn't have what would be referred to as air bypass valves in the exhaust, so we were using keeping the throttle open. And the main downside with that is the lack of engine braking. And so the driver we had in the car was a lovely French guy, and he's a rally driver, so he's used to anti-lag and he knows what comes with that. But at the same time, we had trouble making him very comfortable in the car, so I never went particularly aggressive with it, but it did help a little bit. He said it was a small assistance, but I basically didn't go nuts. So if you're jacking the throttle open.
So again, I guess to just break that down for maybe people who aren't sort of understanding what that all means, there's two ways of getting the anti-lag, which is essentially combustion in the exhaust manifold or exhaust system that then in turn provides energy to spool the turbochargers. But the two ways of getting that air through the engine, one of them, as you mentioned, crack the throttle plate. But then essentially we've got fuel and air being combusted in the engine still to some point. So it tends to create a bit of push. The car doesn't tend to want to slow down when you get on the brake. And the other way of doing that is, I call it fresh air anti-lag, where you're actually introducing air pre-throttle straight into the exhaust manifold. So kind of you can go a lot more aggressive with the anti-lag strategy without those downsides in drivability.
That's exactly right. Yeah, and we just... we will do that again if we use that car next year. But we didn't have the hardware to do a fresh air anti-lag system. So we just used the throttle instead.
What sort of things are you monitoring with that anti-lag strategy? Because it can create a huge amount of, can cause damage to turbochargers, exhaust valves. It's pretty nasty on things, particularly for the Pikes Peak run up the hill. It's quite a long hill climb. So are you using any sort of strategies to sort of monitor and control that for safety?
Yeah, so we have EGTs in every runner. So we have exhaust gas temp in each runner, and there are certainly safeties that are present in the stock GP packages from Motec and M1 that allow you to turn it off if stuff gets really heavy. But I didn't do much to the anti-lag as it comes from Motec because it's fairly comprehensive and fine in my mind. So you're turning it off if it gets too hot. Is the short answer.
Yeah. Okay. Now we've done another podcast previously with Shane Tecklenburg, who we went deep into changes in tuning for altitude. So I'm not going to kind of go over that same ground again. What I'm interested to know, once you've got that calibration done at Colorado on a racetrack, and then the car's gone up the mountain, what were you kind of looking for? Had you made some assumptions on what was going to happen as the barometric pressure changes, or are you relying on closed loop fuel control there to sort of get you out of a jam if things aren't quite where you expected them to be?
Yeah, so I have modified some of the Motec firmware to take into account barometric pressure, and to use that, and airbox pressure specifically, to use that as a barrier compensation, really similar to what Shane was doing. And I don't rely on the Motec Lambda control as much, because I don't rely on it as it sits in the stock GP packages. It's subject to some deficiencies in my mind. So the sort of max-min authority I give closed loop Lambda over the ECU, even with my code that's a traditional PID, is not more than 10%, because it doesn't. If you need more than that, then something is wrong with your math.
Yeah, and I think it's a lot of tuners these days are trying to use things like closed loop fuel control to circumvent doing their job properly in the first place. And I mean, it's definitely not there as a replacement for tuning the VE table properly. And I always sort of say I like to see those closed loop trims no more than maybe plus or minus maybe 2 to 3%. You've got something pretty well on point if it's there, maybe as much as plus or minus 5%. But generally, if I'm seeing those trims consistently outside of that range, I'm going to go back and address that in the VE table. I'm not relying on that closed loop system. Yeah,
exactly. I mean, one of the screens I have up in I2 for analysis for that car specifically is just a scatter plot of bank 1, bank 2 fuel trim plotted over engine speed with transients removed. And that's a great way to tell really quickly if you've got some kind of big problem.
Yeah, I think the scatter plot's a nice way of being able to analyze a huge amount of data, because when you're looking at like a full run up Pikes Peak or even several laps of data around a racetrack, it can be very difficult when you're just looking at a time graph of that to spot a trend. Yeah. Well, obviously we can't spot a trend, so yeah, XY scatter plot, I should say, is a nice way of gathering all of that data together.
Yeah, totally agree. I try to make scatter plots of everything if I can help it. Time series data is somewhat useful, but in most cases, if you're trying to do a quick analysis, you should be able to look at it and be like, okay, this is good or this is bad.
Yeah. All right, we'll move on. For those who are wondering, the car did go very well up Pikes Peak in its debut year and set a new record and won its class. What was the time up the hill?
9:27, I think, is what it was in 2019. And this year in 2021, we also won the car. Thankfully, we went in the dyno before this event, so at least we were able to sort that out. But this year we won our class as well, and we're 5th overall. But we didn't run all the way up the mountain due to weather, so it's only 2 of the 3.
It makes it a bit tougher. Out of interest, how much more power was there when you actually did get an opportunity to go on the dyno?
Yeah, so
compared to your road tune.
Yeah, so we made, I think estimated, because we never put it on the dyno. Previously, we were making around 850 or 900 at the tire, and this year we were making 1100 at the tire, and that's tapped out though. There's no more boost to be had, or I should say, no more turbo speed to be had.
Yeah, I mean, I don't think too many people would complain with 1100 horsepower in that chassis. It's probably
drivers will always find a way.
Yeah. All right, let's move on. So another aspect, and I mean, this is starting to get a little down in the weeds, but I know there'll be a few people who are interested in this. It's a couple of products that you've actually developed and produced yourself, and I've sort of watched some of your posts on Instagram over the last little while about these, and watched with interest. So your INS and IMU, and we've probably straight away lost a lot of people. So can you give us an understanding of what those two bunches of letters actually mean?
Sure. Well, those of you who are still here, thank you. The INS is an inertial navigation system. That's what it's referred to. That's what the acronym means. And the IMU is an inertial measurement unit. And the two differentiating factors of those is that the INS is a GPS plus IMU sensor that has onboard sensor fusion. So this takes the advantages of a GPS sensor, a GPS receiver, and the advantages of an IMU and couples them together to make this sort of like super sensor output. And the IMU, maybe we can talk about this more at length at some point, but the product that I'm calling the IMU is, there are other products on the market called an IMU that traditionally that means there is a three-axis accelerometer and a three-axis gyroscope.
Yep.
Producing raw data. So for instance, the race grade IMU is an example of that, where it was just three axes of acceleration and three axes of angular velocity. That's fine. What my sensor is, the IMU has, my IMU, I should say, has a three-axis accelerometer, a three-axis gyroscope, three-axis magnetometer, and a barometric pressure sensor and a temperature sensor. And it takes all of this information and fuses it together to provide, in addition to all of those things, roll, pitch, and yaw at high rate, at high update frequency. And it will provide velocity and position given a start signal. So this is targeted at drag racing or sprint applications specifically.
All right, so roll, pitch, and yaw data. I mean, obviously the three-axis G sensor is nothing new, and we've had those for a long time. So it's all well and good. People looking to maybe purchase an IMU, that's great. What is the value of that data in roll, pitch, and yaw, and how can we actually utilize that to make the car work better, go faster, tune the chassis, tune the driver, whatever we're trying to do?
Yeah, so in both of these sensors, the INS and the IMU, the roll, pitch, and yaw data is very valuable. A simple example is for a drag racing application where a car is pitching up under a power wheelie as it leaves the line. If you have high enough rate pitch information, you can build a control loop to, as the car comes up, you can soften the engine or reduce torque and have it not come down and smash the oil pan, or just general as a safety item. Yaw rate, or yaw specifically, is another great safety feature. You can put it into a control loop to activate a safety if yaw rate exceeds some value, or if yaw deviates by some degree from what is straight down the track, for lack of a better word, throw the chute or something.
So throw the chute out. Yeah, okay. Now, obviously, wheelies on a road course probably not too relevant, but the yaw data there, can we learn from that around the chassis balance in terms of understeer and oversteer? Yeah,
so a more interesting application maybe from that is with the INS, you get velocities in the body frame, which is quite simply put, if you imagine an IMU or an INS placed in a vehicle such that the x-axis is pointed forward, the y-axis is pointed left, and z-axis is pointed up. That coordinate frame describes the vehicle. And so if you're driving straight, we'll say at 10 meters per second, you're driving straight, you have a velocity in the x-axis of 10 meters per second, and 0 in the y-axis and 0 in the z-axis. So if you're doing, if you are about to run into a wall, maybe you have only lateral velocity, which should be really scary because you can't do anything about that, right? So you would have a velocity, x velocity of 0 meters per second, and then a velocity of 10 meters per second in the y. So that's the vehicle sliding into a wall exactly sideways.
Yep.
So the ratio of the y velocity to the x velocity is slip angle. And the output of that is very useful for describing sort of driving dynamics and behavior. So that INS sensor has been benchmarked against very, very expensive optical sensors and much higher end GPS IMU systems, and has done very well for its price and size.
I think that's probably a key aspect, which is definitely getting well beyond my level of understanding. But just reading some of your posts, that these products that we see on the market, they're not all created equal, and the accuracy and repeatability of the signals that we're receiving from them differ vastly depending on the hardware, which obviously comes down to the cost, and then also, from what I can understand from your posts, again, the filtering that you're applying and how smart that is.
Yeah, that's exactly right. So all the products that are commonplace in the motorsport world at the sort of sub WRC F1 level are basically just 3-axis accelerometers and 3-axis gyroscopes, and that's it. Yep. So there's no math that's done on board to provide you these sort of derivatives of those sensors. So as an example, I call my product an IMU, but perhaps I'm not much of a business or marketing person. So maybe I should have called it something else, but it provides all of that data that normal IMUs in the motorsport market provide, plus acceleration bias filtering, acceleration bias mitigation, orientation estimates, which is this roll pitch yaw that we spoke about, and then also this sort of velocity estimation too, which is
sure,
very useful, I think, for a lot of people. And so I sort of identified that there was a hole in the market there, and I was fortunate enough at my last job to play with a lot of these sensors that are sort of unattainable to civilians. So we get these really fancy robotic sensors, and I just thought they were cool. I guess at the baseline, I think it's awesome, and I'm really sort of interested and passionate about filtering and inertial sensing. Yeah. Hey, maybe that's obvious.
I think it's probably worth saying that these products that you've specifically made, as you say, to fill a hole in the market, these probably aren't a requirement for those of us maybe at the club level, and I'm guessing you've focused these more on that sort of higher level, semi-professional to professional motorsport, as you say, somewhere below the F1 and WRC level. Yeah,
that's exactly right. And I honestly, these sensors started out as just something I thought would be cool because I wanted one, and it turned out that I didn't think the price, like these sort of cost me a lot to make, and I'm not trying to make a pity party for myself because they're expensive, but I don't want everyone to buy one of these. I think that most people can get away with a basic IMU in this case, like the commonplace ones, but the people that responded really positively to these sensors are folks that are used to spending, between, I don't know, $10,000 to $20,000 on a GPS system. So it's definitely a different market than normal people. So these are folks like, Tesla and Ford have bought them. Ford Performance, RTR Motorsports have bought one. It's just like, these are not your run of the mill tuner shops that are buying these things. These are guys that are really looking for data at a very, very high rate and very high accuracy. So you haven't had to put these on the shelf with your unsold sim kits? No, thankfully they're doing better than the poor simulators that I have in a trash can back there somewhere. Good. Obviously you've learned as time's progressed. All right. Question we like to ask: if you could look back on your career up to this point, and it's been a pretty winding journey from what we've learned so far today, maybe not mainstream from the people we normally talk to, but interesting nonetheless, is there any advice you'd give to a younger version of yourself that may have helped you avoid some of the pitfalls or speed up your trajectory? Yeah, I think the thing that I would tell my younger self is to just do it. Don't worry about trying to overthink things. I think a lot of the struggles I had early on were just based on trying to sort of painfully plan about how I would go from buying an M800 that I couldn't afford at the time and, become a Motec dealer. And then I was going to do this many cars per month and it was just going to be great. And I had, I was going to build a shop and I had this whole list of things out that I was going to buy. And really it just got down to this like kind of analysis paralysis of just, nothing happened. And then
I 100% agree.
Yeah. It just
so many people do get stuck in that analysis paralysis sort of no man's land. And I mean, obviously a plan and a general goal or direction is important, but at some point you do also have to just commit and start working towards it. And what I've always seen as well is you can have the best laid plans, and then you take that first step and everything changes, and it's about being flexible and being able to adapt to what you find as you start down that journey, I think.
Yeah, totally agree. And just to not worry about, I mean, this sounds insensitive to say being in a place where I am now, but just don't worry about money. Money doesn't matter. Like don't worry about charging people. Like you have to charge people to make money. I understand that as a business, but it sometimes it's just, you just need to do it. And, you'll learn more things. You'll learn more that you don't know, by doing it than just sort of, planning for, and then worrying about money and all this stuff. Like you gotta do what's right for you and your family, but at the same time, it's stuff always doesn't have to make like perfect financial sense.
No, I 100% agree. And I think a lot of us in the automotive world probably got into it because of passion over money. And certainly if becoming very wealthy was your main driving goal, there's probably alternative career paths that might make a little bit more sense. But at the end of the day, we all have our different motivations for doing this. But I've always believed that if you're passionate about what you're doing, you're going to at least enjoy it. That's really important because you spend so much of your life working. And then if you're good at what you do and you do quality work and you keep your customer base happy, then the money in one shape or form will come as a result of that.
Yep. Totally agree. Yeah, the podcast you did with Scott was the ending of that was just perfect. Scott's such a cool dude. To hear him sort of lay it out like that was right on. It was really cool.
Scott Cooner from Mtron. Just for those who haven't maybe listened to that episode, yeah, absolutely. He maybe went a little further than most with the sort of jump out of the airplane and build the parachute on the way down. But I mean, again, exactly what I was saying. It's worked out for him. He's got a very viable product and a thriving business as a result.
100% agree.
Right. If people want to follow you and find out a little bit more about what you're up to, how can they do that? Where should they go?
Yeah, the best course of action, I think, for that, if you're interested, is I try to keep my Instagram happening, at least occasionally when I do stuff that I think is interesting. That's one word, lambda of one, on Instagram. And then my Facebook page is more or less the same. It's just facebook.com Obsidian Motorsport. So that's
perfect.
Yeah. Yep.
And I can attest to, for those who are maybe a little bit more technically inclined, like myself, following Sander will definitely open your eyes. All right, Sander, as an avid mountain biker that you are, hopefully once this COVID thing blows over, we can see you down here in Queenstown and head out on some of the trails around here.
Oh, I'd love that.
I'm sure you'd love it here.
I would love that for sure. It's definitely on my bucket list.
Perfect. All right, thanks heaps for your time, Sander, and look forward to chatting again later.
Okay, dude. Talk to you later.
All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 $75 off the purchase of your first course. You'll find our full course list at hpaacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpaacademy.com/courses.